Hey everyone, this is Professor Chan from Math 1245 speaking. We're going to continue on with section 3.2. Now remember, back in our prior video, we talked about different characteristics of polynomials and how to graph them. So let's talk about the following. So we are going to kind of converge all these prior topics, right? Highest degree, my power function, my zeros, my turning points, and all that stuff, and talk about how to approximate a graph. Okay, so you'll have a problem like this here. Okay, and you want to make sure you know how to just kind of summarize all these and then kind of make an approximate graph for the following here. So let me give you an example. This is number 2. So number 2 says the following. We have x minus 1 times x plus 3 squared. And we want to talk about different properties that we see. So highest degree, let's remember, right? This is degree 1. This is degree 2. 1. So exponent of 1, exponent of 2. 1 plus 2 is 3. And it's positive. So my highest degree is f of x is equal to x cubed. So let's kind of understand what's happening, right? So I'm going to kind of like look at this here, right? So idea is at the ends, it's going to look something like this. Okay. So now I'm going to find my x-intercepts, right? My x-intercepts are what's called my zeros. So let's take a look. So first one I have is x minus 1 is a factor, so I set it equal to 0. So I have x is equal to 1, and that's a multiplicity of 1 because I only have one exponent here. And then I have x plus 3. I set that equal to 0. I have x is equal to negative 3, which is a multiplicity of 2. Okay, this one is odd, and this one is even. Okay, and now I'm going to find my y-intercept. So my y-intercept, remember, is when x is equal to 0. So I'm going to do f of 0 is equal to 0 minus 1 times 0 plus 3 squared. So f of 0 is negative 1, 3 squared. This is equal to negative 9. Okay. So let's talk about this. So I'm going to make a rough sketch here. So let's look at what some of the points I have so far. So I have here 0, negative 9. I'm just going to do a rough approximation. So I have 0, negative 9, which is right here. And I have 1, 0, and negative 3, 0. Okay, so let's talk about what's happening here, okay? So let's talk about this. I know my ends, right? So my end behavior is it's going to go down, right, when it's coming to the left, and it's going to go up when it's going to the right. I also know that the following here, that I have zeros at negative 3, 0. I have a y-intercept at 0, 9. This is an approximation, and a 1, 0 here. Now, I also know negative 3 is even. So here's the thing. So look at my end behavior. And so the idea is, as I'm going to the right, it's going to go towards negative 3, 0. But notice as I go to negative 3, 0, it is going to be even. So it's going to bounce back. So remember, when it's even, it's going to touch. But if it's odd, it's going to cross. Now x is equal to 1, so it's going to go out, and it's going to cross out, like the following here. Okay? Sorry, let me redo that part again. It'll look something like this here. Okay. So I'm doing kind of a rough sketch. Okay. Kind of see what's happening here. And then I'll look at how many turning points. I have 1, 2. I have 2 turning points. Now let's think about this. This should make sense because what's my highest degree? It is 3. So remember my rule, my general rule of thumb is highest degree of 3, and that is 1 more than 2 turning points. So that makes perfect sense. Okay? So if we're not sure if we did this right, we're going to use our graphing calculator to check. Okay, now here's the thing, okay? Your graph that you're going to do a rough sketch by hand may not match your calculator. The thing that we're focused on is we're focused on the end behavior, if it's correct, right? If my intercepts are correct, and if I have the same turning points, and if it crosses and touches in the correct places. Okay, so let's look at this. So let me erase all this here. And I have x minus 1. And then x plus 3 quantity square. And I'm going to graph this. So as you can see, we're pretty close, okay? Now the thing is, okay, don't worry about like how wide, right? Don't worry about that. Look at kind of where it's hitting. So notice it is -3, 0. It touches, goes down at 0, 9, crosses at 1, 0. So we're good, okay? So it matches. Okay, and then you'll focus on kind of like what your domain and range. Okay, so here, notice my domain according to my graph is -infinity to infinity, and my range is from -infinity to infinity. Okay, as you can see, right? Okay, and then you can figure out it's increasing, decreasing. Don't worry too much about that because sometimes it's a little bit hard to see. Okay, for the following. So that's kind of it for kind of compromising everything together, right? So you're going to use your characteristics of the things that they give you, and then you can kind of do a sketch and then check with your calculator to see if it's roughly about the same, okay? Sometimes I'll be a little bit off, okay, but again, just focus on end behavior, turning points, your zeros where it crosses or touches, and your intercepts, okay? So let's look at, okay, yeah, let's look at this one here, okay? So I'm going to do one more example. So I have here -2 times x plus 2 times x minus 2 cubed. So the thing I realize it's negative, and I also notice I have x cubed, so it'll be -x to the 4th, okay? So I don't know what's going to happen in between, but I do know it's going to go down on both ends because it's even and it's negative. Okay, let's look at my x and y intercepts. My x-intercepts are my zeros. So I'm going to set both of these. I'm going to set x plus 2 equals 0 and x minus 2 equals 0. So I have x is equal to 2 and x is equal to -2. This x plus 2, sorry, that -2 has a multiplicity of 1. And then x equals 2 has a multiplicity of 3. Both of them are odd. Sorry, both of them are odd multiplicities. So at -2 and at 2, they're going to cross. Now, if you look at kind of my end behavior here, okay. Now, I have no idea kind of what's going to happen, but I do know they're both going to cross, right? So the one on the left is going to go from bottom up, and the other one's going to go top to bottom here. Okay. how many turning points should I have? I should have mostly 3. Okay. Now, I have no idea what it will look like. Maybe it might look something like, I don't know, this or something like that. Maybe not. Okay. But at most, we should have 3 turning points. But we can make it like a guess, and I'm like, maybe it goes like this, and maybe it like changes something like that right there. Okay. Oh, sorry. I also want to figure out my y-intercepts. That may change everything. So y-intercept is when x is equal to 0. So f of 0, -2, 0 plus 2, 0 minus 2 cube. Yeah, that may change everything. So I have -8 times 2 times -2. And that is 32. Okay, so that changes quite a bit. My apologies for that mistake. So 0, 32. I don't know. I'm going to make an approximate here. Maybe it may look something like this. Okay. Just doing a rough guess. Okay. And then check using graphing calculator. Now, here's the thing, okay? Coming into this, we may not realize, okay, we should realize our graph here that we're going to sketch in our calculator is not going to be the same as, it's definitely not going to be the same as what we sketch out, but you're just focused on your end behavior and your intercepts, okay? And we should have just at most 3 turning points. So x plus 2, parentheses x minus 2, let's graph. Wait, did I? Sorry. Oh, whoops, sorry. X plus 2, x minus 2. Let me do zoom fit. Sorry, let's try this one more time. Yeah, kind of a thing is if you messed up, just delete the whole thing and start all over. There we go. Let's take a look at this. Yep, okay. Yeah, so actually this is kind of a good thing to discuss. So how do I know what I was graphing was not correct, other than the fact that I may have done this before? Okay, so if you notice the one that I was graphing, notice my ends were, it was going up to the left, but then down to the right, which doesn't make sense because if we look back to our problem, it's x to the 4th, and that's even. Okay, this is a more accurate graph because if you notice they're both going down and it's negative, and that makes sense here. Okay, now I can't see the whole picture. I can go to window, make my y max a little bit larger. Okay. Here's the thing, okay? Actually, I should probably make it 40 because I know my y-intercept is 32. So here's the thing, okay? We don't care too much about like the curve, right? So as you can see, the curve on my right is probably not the same as the calculator. But the thing is I'm focused on, right, is I'm focused on whether or not my intercepts are the same, which as you can see they are, and whether they cross and touch at the same point, which they both are. I have my y-intercept and my end behavior is the same, okay? And then my turning points may not match with my sketch, but it should be less than 4 because I have a degree of 4. Okay? Yeah, and that's it. Okay. So yeah, keep practicing these. Okay? If you have questions, send me an email. But yeah, you're just focused on looking at each of these intrinsic characteristics and then checking if it matches with what you throw in your graphing calculator. Okay? Try to do some of this by hand, okay? Because on the concept checks or potentially on the test, you may have to do this. And obviously, if you're doing this on MyMathLab, a lot of times they just tend to just give you pictures, which is fine. But yeah, you want to make sure you know how to kind of construct it in and out, doing this by hand. Okay. Let's finish up with one last concept, which is called intermediate value theorem. Okay. So if I have a polynomial function, now here it is, you have a definition that is kind of long, but essentially what we're saying is if I have a and b, right? So let's say I have this polynomial right here. Sorry, that was pretty bad. So let's say I have this polynomial I graph, right? And it's like this here. Okay? So what we're saying is I have a point when x is equal to a, and I have a point when x is equal to b. Okay? So notice the y value when x is a is positive, right? And then notice the the y value when x is b is negative. Since my polynomial, every polynomial graph is continuous, and since my a is positive and my b is negative for my y values, that means there has to be a point C such that it changes. A point C such that y is equal to 0. Okay? Because if the y value for A is positive and the y value for B is negative, that means it has to decrease. Okay? And because it's a polynomial, it's continuous, right? There's no jumps or skips. Okay? So, it says use the intermediate value theorem to show that each polynomial has a real 0 given the integers. Okay? So all I have to do is I'm plugging in 1 and 2 and see if I have a real 0. So if I plug in 1, if I plug in f of 1, this is equal to 1 cubed minus 1 minus 1. Okay? So I have 1 minus 1 minus 1, that is negative 1. So notice f of 1 is negative. Let's try f of 2. So 2 cubed minus 2 minus 1. I have 8 minus 2 minus 1. That is 5. What does this mean here? This means, so notice at 1, it becomes negative, but at 2 it becomes positive. That means there is a real 0 between 1 and 2. Okay? So at some given point when x is between 1 and 2, it's going to cross the x-axis. Okay. Let's look at one last example. So I have 2x to the fourth minus 4x squared plus 1 between negative 1 and 0. So same thing, I want to see if intermediate value theorem works. So remember, intermediate value theorem works if both of my points, if I plug them in, one's positive and one's negative, right? If they're both positive, they're both negative, it doesn't matter, okay? So I'm going to plug in negative 1, 2 times negative 1 to the fourth, minus 4 times negative 1 squared, plus 1. I have 2, 1, negative 1 squared is 1. This is negative 1. And then plug in 0. This is positive 1. So since it goes from negative to positive, that means there is a 0 in between negative 1 and 0. Okay? So that means it crosses, right? When we say 0, we're saying it hits the x-axis. My graph hits the x-axis when it's between negative 1 and 0 by the intermediate value theorem. Okay, so that's pretty much it. We finished section 3.2. If you have questions, let me know. Other than that, I will see you guys later.